We will study Arrhenius concept of acid and bases in this video. Students, in 1887, a Swedish chemist Arrhenius proposed the first successful theory of acids and bases. Now students, we will see what is the Arrhenius theory, what is the Arrhenius concept of acid and bases. According to Arrhenius, an acid is a substance that ionizes in water and produces hydrogen ions, and a base is a substance that ionizes in water to produce hydroxide ions. Students, once again we will see Arrhenius concept of acids and bases. According to Arrhenius concept, an acid is a substance that ionizes in water and produce hydrogen ions, and a base is a substance that ionizes in water and produce hydroxide ions. We will see some of the important examples of acids and bases according to Arrhenius theory. For example, if we dissolve HCl in water, right students, it ionizes to give aqueous hydrogen ion as well as aqueous chloride ion. Aqueous hydrogen ion plus aqueous chloride ion. Right students? Similarly, if we dissolve sulfuric acid in water, H2SO4. If we dissolve sulfuric acid in water, students, then sulfuric acid ionizes to give 2 hydrogen ions, since there are 2 hydrogen atoms present in 1 molecule of sulfuric acid. So 1 molecule of sulfuric acid ionizes to give 2 moles of hydrogen ion, right students, plus 1 mole of sulfate ion. These ions are also in aqueous form, right students. Now we see one more example. For example, if we have nitric acid, if we dissolve nitric acid in water, HNO3, nitric acid, in the presence of water, right students, nitric acid dissociated to give aqueous hydrogen ion, right students, as well as aqueous nitrate ions. By dissolving nitric acid in water, we get aqueous hydrogen ions as well as aqueous nitrate ions. Students, I hope these examples of Arrhenius acids are clear to you. We will see some of the important examples of Arrhenius bases. Students, we know what are Arrhenius bases. These are the chemical compounds which, when dissolved in water, they ionizes to produce hydroxide ions. Right students, now we will see some of the important examples of Arrhenius bases. For example, sodium hydroxide, NaOH. If we dissolve NaOH, that is sodium hydroxide, in water, then it ionizes to produce aqueous sodium ion as well as aqueous hydroxide ion. We get aqueous sodium ion plus aqueous hydroxide ions, right students. Similarly, if we have potassium hydroxide, which is Arrhenius base, potassium hydroxide, when dissolved in water, KOH, right students. If we dissolve potassium hydroxide in water, in the presence of water, it dissociated to give aqueous potassium ion, right students, plus aqueous hydroxide ions. Similarly, we will take one more example. For example, if we have ammonium hydroxide, right students, we know very well what is the formula for ammonium hydroxide. NH4OH is Arrhenius base. If we dissolve ammonium hydroxide in water, now in the presence of water, ammonium hydroxide dissociated to give aqueous ammonium ion, right students, aqueous ammonium ion as well as aqueous hydroxide ions. I hope these examples of Arrhenius bases are clear to you students. We will see some of the important common Arrhenius acids as well as bases. The first acid, common acid, is HCl. HCl is known as hydrochloric acid. HCl is known as, what is the name of HCl? It is known as hydrochloric acid. Right, students? The second important acid is HNO3. HNO3 is known as nitric acid. Nitric acid. Similarly, students, we have another important acid, H2SO4. H2SO4 is known as sulfuric acid. Sulfuric acid. Right, students? We'll write one more example of acid. For example, if we have another important acid, H3PO4. H3PO4 is known as phosphoric acid. Phosphoric acid. Students, I hope these examples of acids are clear to you. Now, students, we will see some of the important examples of bases. Right, students? So, we will write some of the important examples of bases. For example, the first important example is NaOH. NaOH is known as sodium hydroxide. Similarly, another important base is KOH. KOH is known as potassium hydroxide. Right, students, we will see some more examples of bases. For example, we have calcium hydroxide, CaOH whole twice. This is known as calcium hydroxide. Another important example is MgOH whole twice. This is known as magnesium hydroxide. Student, I hope concepts of Arrhenius concept of acid and bases and examples are clear to you. We will discuss limitations of Arrhenius theory. Let's start the session. Arrhenius theory just apply to aqueous solutions. It does not explain that sulfur dioxide and carbon dioxide, these compounds are acidic in nature. Arrhenius theory unable to explain that why carbon dioxide and sulfur dioxide, they are acidic in nature, although both the compounds, they do not contain hydrogen ion. Both the compounds do not contain hydrogen ion, still they are acidic. Right? Similarly, we can also not explain why ammonia is a base with the help of Arrhenius theory. NH3, it is a base. It cannot be explained with the help of Arrhenius theory, although ammonia do not contain hydroxide ion, but still it is a base. Now, students, we will see defects of Arrhenius theory. There are certain substances which do not give hydrogen ion, but still they are acidic in solution. For example, aluminium chloride. Aluminium chloride, when dissolved in water, it do not give in water. Right, students? It do not give hydrogen ion, but still it is acidic in character. Similarly, ammonia, NH3, it do not give hydroxide ion in water. Ammonia do not give hydroxide ion in water, but still it is basic in nature. So There are certain substances which are acidic as well as basic in nature, but by using Arrhenius theory, we are unable to explain their acidic and basic nature. These are the limitations as well as defects of Arrhenius theory. I hope these are clear to you.